In the previous video, we discussed the rhombus, a particular parallelogram with all four of its sides being congruent. Here we will learn about the trapezoid, which is our fifth quadrilateral after squares, rectangles, parallelograms, and rhombi. Trapezoids are similar to parallelograms in that their top and bottom sides, called bases, are parallel to one another. However, their other two sides, called legs, are not parallel, which would disqualify them from being classified as parallelograms. Trapezoids are distinguished from other quadrilaterals by having one and only one pair of parallel sides. Trapezoids also have two pairs of base angles. The first pair is the pair of angles that share the bottom base, and the second pair are the other two angles that share the top base. These angles are called base angle pairs. The trapezoid currently being displayed is an example of an isosceles trapezoid, in which the two legs are congruent. Any trapezoid that is not isosceles does not have congruent legs. Does isosceles sound familiar? It's the same name we give to triangles that have at least two congruent sides. There are four main theorems that relate to trapezoids. Three of them apply only to the isosceles trapezoids, and one of them applies to all trapezoids, called the midsegment theorem. Let's begin with the midsegment theorem. As the name suggests, the midsegment theorem refers to the line that can be drawn from the midpoint of one leg to the midpoint of the other leg. The theorem states that the midsegment is parallel to both bases, and that the length of the midsegment is 1/2 the sum of the length of each base. For example, if this trapezoid has a base length of 4 units, another base length of 2 units, then using the following formula, m equals 1/2 times base 1 plus base 2, we can plug in 4 for B1 and 2 for B2. 4 plus 2 equals 6. 6 times 1/2 equals 3. The length of the midsegment for this trapezoid is equal to 3. The next three theorems only apply to isosceles trapezoids, which have congruent legs. These theorems are the three conditions we will use later to test whether a trapezoid is isosceles. The first of which states this: isosceles trapezoids have congruent diagonals. Any trapezoid without congruent diagonals will not have congruent legs, disqualifying it as an isosceles trapezoid. The next two theorems refer to the trapezoid's angles. For a trapezoid to be isosceles, both pairs of base angles must be congruent. If any pair of base angles were not congruent, the legs would also fail to be congruent, and the trapezoid would not qualify as isosceles. The final theorem regarding isosceles trapezoids states that if a trapezoid has at least one pair of congruent base angles, the trapezoid must be isosceles. Essentially, if you knew for certain at least one pair of base angles were congruent, you could logically conclude that the other two must also be congruent with each other according to this theorem. Let's test some trapezoids to see if they are isosceles. Remember, the trapezoid only needs to satisfy one of the three previous conditions to be considered isosceles. Here is our first example. With this trapezoid, we are given information about the length of each diagonal. However, the lengths are not equivalent, and therefore the diagonals are not congruent. According to the first condition of isosceles trapezoids, this shape is not isosceles. Example number 2. Our next trapezoid comes with information about each angle measure. The two angles below both measure 45 degrees. The top two angles both measure 135 degrees. This satisfies the second condition, which required both base angle pairs to be congruent, proving that our example is indeed isosceles. Example number 3. Our final example only includes information about the top two angles. Looks like both angles are congruent, and since both angles share the same base, they are considered base angle pairs. Given the third condition for isosceles trapezoids, our example must be isosceles, since at least one base angle pair is congruent. With the time we have left, we will discuss how to calculate the area of all trapezoids, whether they are isosceles or not. First, we must determine what the height and bases are of our trapezoid. The height is the length of the auxiliary line drawn perpendicular to the bases. and base 1 and base 2 represent the parallel sides of our trapezoid. It doesn't matter which one is which. The formula for the area of a trapezoid is A equals 1/2 times h times b1 plus b2. Here's where the formula comes from. If we make a copy of our trapezoid and turn the copy upside down and align it like this, we have a shape that looks like a parallelogram. Do you remember how we determined the area of a parallelogram? We split the shape like this and formed a rectangle, which has the area of length times width. The length represents the sum of lengths of base 1 and base 2. The width represents our height. So the length of this rectangle is b1 plus b2. But remember, we use two trapezoids to make this rectangle, which means that the rectangle is twice as big as a single trapezoid. That's why we cut the whole value in half by including this fraction in our formula. Again, the formula for the area of a trapezoid is A equals 1/2 times height times b1 plus b2. Let's look at a quick example. Our trapezoid here has a base length of 2.5 and another base length of 3.5. The height has a length of 2. According to our formula, plugging in our values will give us A equals 1/2 times 2 times 2.5 plus 3.5. 2.5 plus 3.5 equals 6. 2 times 6 equals 12. 12 times 1/2 equals 6. Our area is equal to 6 square units. In summary, trapezoids are quadrilaterals with only one pair of parallel sides. This property is the most unique feature of the trapezoid. Our final quadrilateral of study will be a familiar figure, the kite. In the next video, we will examine its special properties.